In this section, I will talk about the properties of chords of a circle. There are three categories of concepts to be discussed in this video, and I will go over this one by one. The first category is about the properties of a chord and a line. Consider this situation. Suppose there is a chord of a circle and a line is drawn from the center to the chord, such that they are perpendicular to each other. In this chapter, we should learn that this chord should have been divided into two equal halves by this perpendicular line drawn from the center. The reference of this property is known as perpendicular from center to chord bisects chord. To understand why the perpendicular from center to the chord always bisects this chord, we can consider these two triangles OAP and OBP. Because OA and OB are radii of this circle, they are equal. Therefore, it can be proved that triangles OPA and OPB are congruent because of RHS, and hence PA is equal to PB because they are the corresponding sides of this pair of congruent triangles. As a result, if a perpendicular line is drawn from the center to the chord, AP must be equal to PB, and therefore this chord is bisected. Now let's consider another situation. Suppose we have a chord of a circle and suppose this is the midpoint of this chord. If we join the center and this midpoint of the chord, this line should be perpendicular to the chord, and this property is referred as line joining center to midpoint of chord perpendicular to chord. Let's see why these two lines are always perpendicular to each other. Again, we consider triangles OAP and OBP. This time we should be able to prove that these two triangles are congruent because of SSS. Therefore, angles OPA and OPB are equal because they are the corresponding angles of the congruent triangles. In addition, because these two angles are adjacent angles on a straight line, both of them should be a right angle. As a result, the line joining the center to the midpoint of the chord should always be perpendicular to the chord. Finally, let's consider this situation. Suppose we have a chord and this is the midpoint of this chord. We can draw a perpendicular line from this point so that it is the perpendicular bisector of this chord. We should know that the center of this circle should actually lie on this line somewhere. This property is referred as perpendicular bisector of chord passes through center. To prove why the perpendicular bisector of a chord always passes through the center, first of all, we can assume that the center O does not lie on the perpendicular bisector PQ. Here from the diagram, we can see that the angle OPA is less than 90 degrees. However, by considering line joining center to midpoint of chord perpendicular to chord, angle OPA should be a right angle. Therefore, we can see that there is a contradiction by assuming that the center O does not lie on PQ. As a result, this assumption should be wrong, and therefore the perpendicular bisector of a chord should always pass through the center of the circle. So far, we have learned these three properties of a chord and a line. It seems to be a lot of information, but this can be summarized in a simple way. Actually, there are three types of relationship between a line and a chord. A line can bisect a chord, a line can be perpendicular to a chord, and a line can pass through the center. As you can see, if two of these conditions are given, we can conclude that the third one is also true. And that's how we can distinguish between these three similar but different properties. Now we come to the second group of properties related to chords. This is about the properties of two chords. Suppose now we have two equal chords of a circle. If we consider the perpendicular distance from the center to these two chords, they should be equal. This property is referred as equal chords equidistant from center. Again, we can prove this property by considering congruent triangles. First of all, we should know that AP is a half of AX by considering perpendicular from center to chord bisects chord. Similarly, BQ should be a half of BY. Because the chords are equal, the half of them should also be equal. Therefore, AP is equal to BQ. Now it can be shown that triangles OPA and OQB are congruent because of RHS. Hence, OP is equal to OQ as they are the corresponding sides of congruent triangles. Therefore, if the chords are equal, the perpendicular distance from the center should also be equal. Now let's consider another situation. Suppose we have two chords and they have the same perpendicular distance from the center. we can actually conclude that these two chords are equal, and the reference of this property is chords equidistant from center are equal. Let's see the proof of this property. Here we can directly conclude that triangles OPA and OQB are congruent because of RHS. Therefore, AP and BQ are the equal corresponding sides. Furthermore, by considering perpendicular from center to chord bisects chord, AX should be a double of AP and BY should be a double of BQ. As a result, AX must be equal to BY. That's why when two chords are having the same distance from the center, they must be equal. We can have a similar summary table for this group of properties. We need to consider two kinds of relationship of chords. One is about equal chords, and the other one is being equidistant from the center. If one of these conditions is given, we can conclude that the other one is also true by referring to one of these reasons. Now we come to the last part of this video. It is about the circumcircle of a triangle. Take a look at this triangle. Suppose we construct the perpendicular bisectors of the blue side and the green side. If I call the intersection to be O and I join OA, OB, and OC, we can see that triangles OAP and OBP are congruent because of SAS. Therefore, OA is equal to OB. Similarly, we can also prove that triangles OAR and OCR are congruent, and therefore OA is equal to OC. That means OA, OB, OC are all equal. Because these three lengths are equal, when we consider O as the center and OA as the radius, we should be able to draw a circle passing through the points A, B, and C. In this regard, a circumcircle or a circumscribed circle of this triangle is constructed. On the other hand, because we have learned that the perpendicular bisector of a chord always passes through the center, if we draw a perpendicular bisector of the orange side, it should therefore pass through the center of this circle. As a result, all of these three perpendicular bisectors should pass through the same point, and that is the center of this circle. Therefore, the intersection of these three perpendicular bisectors is called the circumcenter of this triangle. For the radius of this circumcircle, it is called the circumradius of this triangle. After that, we can draw this conclusion. For any triangle, we can always draw a circumcircle, and at the same time there is only one circumcircle. The reason is that the position of the circumcenter is fixed by the intersection of the perpendicular bisectors. To summarize this video, we have learned three categories of concepts related to chords. The first one is about a chord and a line. The second one is about two chords. And finally, we talk about why and how we can construct a circumcircle of a triangle by considering its perpendicular bisectors.